Okay, hello and welcome to another live stream. Today's paper is October-November 2024 6-3. I will begin solving. Out of focus here. Okay, so starting with the first question. It says the heights of certain species of deer are known to have a standard deviation of 0.35. A zoologist takes a random sample of 150 of these deer and finds that the mean height is this. I think this is the same paper as the one before. Yeah, okay. So let's pick out a different paper. I think I will have to change the name of the stream. Give me a moment to do that. I don't think I'll be able to do that right now, but I think I'll be able to do that in a bit. But let's do paper that we haven't done. I think that should be June 24. Let's do June 24, 6-1. Okay, this says a bus station has exactly 4 entrances in the morning. The number of passengers arriving at these, I think I haven't figured. I think this is May, June 24, and the variant is 6-1. Okay, a bus station has exactly 4 entrances in the morning. The number of passengers arriving at these 4 entrances during a 10-second period have the independent normal Poisson distributions as this is this. Find the probability that the total number of passengers arriving at the 4 entrances to the bus station during a randomly chosen 1-minute period, the morning, is more than 3. So I just want 1 minute. So first what I'm going to do is I'm going to add all of this for 10 minutes, 10 seconds, and then convert it to 1 minute. Okay, and since this is for 10 seconds, I just need to multiply it by 6 to get it for 1 minute. 0.4 plus 0.1 plus 0.2 plus 0.5. Fine. Okay, what am I getting? Into 6, 36.5, that's 7.2 is what I'm getting. And I want one is more than 3. I want the probabilities of 4, 5, 6, and so on. Instead, I'm going to do probability of 1 minus probability of 0, 1, 2, and 3. So 1 minus e power minus lambda minus e power minus lambda minus e power minus lambda to lambda power r over r factorial plus okay. 1 minus 0.0719 0.9281. Okay, let's check if that answer is correct. Let's go on. I don't think I have the marking scheme for this. I will have to download that. Okay, I think we'll keep this. And yeah, that is the correct answer. Okay, question number 2. The random variable x has the distribution this. The independent random variable values of x denoted by x1 and x2 are chosen. Find probability of x1 is greater than 3 times x2. Okay, so I will call that question on multiples. Okay, so the first thing that I'm going to do is x1 is minus 3 times x2 is greater than 0. So the difference is called x1 minus 3x2. Okay, and yeah, okay, so the mean is going to be 31.2 minus 3 times 31.2, and the variance is going to be 10.4 squared plus 3 squared into 10.4. Let's calculate quickly. Minus 62.4 and 201.7. Okay, so difference is greater than 0. Z is greater than 0 minus 62.4 over root of 201.76. 2.4 divided by 2. I think I have made an error somewhere. Let's check. 1081.6. Yeah, I've made an error in calculating. That's what I thought. This is 1081.6. Because my answer for Z was coming out very large, that told me that I had messed something up. I have 1.897. 1 minus 5 of 1.897. 1.897 from here. 0.89 and 7 means adding 5. 9711. 0.028. Okay, I think let's check. Yeah, that's the correct answer. Question number 3. The times taken by in minutes for a certain daily train journey has a normal distribution with standard deviation 7.8, 5.8. For a random sample of 20 days, the journey times were noted and the mean journey time was found out to be 81.5. A 98% confidence intervals, that means x bar minus z value into sigma over root n is less than mu x bar plus z value. Okay, so x bar is 81.5. The z value is going to be 99% because I have to leave 1% on each side. 99% gives me 2.326. So 2.326. A very similar question in the November 24 series as well, which tells you that the questions keep repeating themselves. Root of 20. $81.56 into 5.8 over root of 78.5 and 84.5. Okay, a student was asked for the meaning of this confidence interval. The student replied as follows: the times for the intervals of 98% of these journeys are likely to be within this confidence intervals. This is an exact repeat of the question. I don't know why. Explain whether the statement is true or not. No. Confidence interval is for mean, is for population mean, not individual values. Okay, then two independent 98% confidence intervals are found. Given that at least one of these intervals contains the population mean, find the probability that both intervals contain the population mean. When it says given that means that this is a conditional probability question. What is the condition? Given that at least one contains, and find the probability that both contain. So at least one contains means that either the first one or the second one or both contain the population mean. Okay, so at least one can also be evaluated by the fact that I can do 1 minus probability that both don't contain the population mean. That's going to be 0.02 into 0.02. Okay, both intervals do not contain the population mean. It has been subtracted from 1, and the numerator has to be both contain the population mean. So that's going to be 0.98 into 0.98. I think that should give you the correct answers. 0.98 into 0.98 divided by 1 minus 0.02 into 0.49 over 51 or 0.961. Let's check if that's the correct answer. 0.961 is the correct answer. Quickly on to question number 4. It says a random sample of 8 boxes of cereal contained. Each boxes was weighed and the masses in grams and then by his estimate of the mean and variance of mean is equals to x bar. Quickly add up these numbers: 261, 249 plus 259 plus 252, 255, 256, 258, 254. 2044 divided by 8. 255 point. Okay, for the variance, you have to do n over n minus 1, so 8 over 7 into sum of x squared divided by n minus the mean square. So I have to square each of these numbers: 261 squared, 249 squared, 259 squared plus 252 squared plus 255 squared plus 256 squared, 8 squared plus 2 was divided by, that gives me 522. 106 over 7, 15.1. That's the correct answer. Okay, part B. The supplier claims that the mean mass of the boxes of cereals is 253 grams. The quality control officer suspects that the mean mass is actually more than 253. In order to test this claim, he weighs a sample of random sample of 100, but the total mass is 2 and finds that the total mass is 25360. Okay, given that the population standard deviation of the masses is 3.5, and at the 5 test at the 5% significance level. So H naught is that mu is 253. The quality control suspects it's actually more than 250. Okay, so 100, and he finds x bar to be 25360 divided by 100 means that 253.6. Okay, let's draw the critical region. I want at the 5% significance level, and I just want the upper tail. So 95 gives me 1.645. 1.45, then z is equals to 253.6 minus 253 divided by standard deviation is 3.5 root of 100. Getting 1.714. Now 1.714 is inside the critical region, so reject H naught. There is evidence that mean is greater than P3. Okay, an employee says this test is invalid because it uses the normal distribution, but we do not know whether the masses of the big boxes are normally distributed. Explain briefly why this statement is true or not. It does assume the normal distribution and is large, so the central limit theorem applies. Okay. Not true CLTUs. Okay, yeah. Sales of phones at a certain shop occur singly, randomly, and independently. State one further condition that must be satisfied for the number of sales in a certain period to be well modeled by. So, average sales is known for an interval, which means that lambda must be known. Let's see if that's the correct answer. Yeah, constant average rate. Constant average sales. Lambda must be constant, basically. Okay. The average number of sales per hour is 1.2. So lambda is 1.2 for 1 hour. Assume that a probability distribution is a suitable model. Find the probability for the number of sales during a 12-hour period. So lambda has to be 1.2 times 12, which should be 14.4. Will be more than 12, less than 16. Either 13, 14, or 15. So e power minus lambda into lambda power r over r factorial plus e power minus lambda into lambda power r factorial 0.309. Check. Yep, that's the correct answer. Part 2, it says using a suitable approximation, find the probability that the number of sales during a randomly 1 month period, which is 140 hours, will be less than 1. Less than 115. I want to use an approximation. This rounds off. Continuity correction leads me to 149.5. Okay, lambda will have to be evaluated. 1.2 into 140 gives me what? 168. So z less than 149.5 minus 168 over root of 168. Z is less than minus 1.427. Phi of minus 1.427. 1 minus phi of 1.427. 9232. 0.076. Checking my answer. Yes, that's the correct answer. Question number 6. The diagram shows a graph of the probability density function of a random variable is a quarter circle entirely in the first quadrant with center 0, where a is a positive constant, elsewhere f of x equals to 0. Show that a equals to 2 over root pi. So pi r squared divided by 4 should be equals to 1. Pi a squared equals to 4. A squared should be 4 over pi. And then a should be root of 4 over pi. 2 over root pi. Then show that f of x equals to root of 4 over pi minus x squared. Okay, so this is equation of the circle. Okay, so the equation of a circle is x minus b whole square, y minus q whole square equals to r square, which is a square. A square in this case would be 4 over pi then. So a square and then 4 over pi here. Center is 0, 0. So x square plus y square equals to 4 over pi. Y square equals to 4 over pi minus x squared, and then the function should be root of 4 over pi minus x. Okay, the expected value of x is basically x f of x. So x into f of x, which is 4 over pi minus x squared. Okay, now that is a little challenging. Again, from 0 to 2 over root pi. Now, we've done this in integration by substitution, that sometimes when the differential of something is visible to you, what you should do is you should take a substitution for whatever is can be differentiated, and the differentiation is visible outside to you. So what I see is that the differentiation of minus x squared is minus 2x, and x is already out there. So what I can do is I can use a substitution that says 4 over pi minus x squared du over dx is going to give me minus 2x. Okay, and then dx is going to be this. So I can write root of u du over minus 2x, and there's an x outside. Okay, so minus half comes outside, and I have root of u. So this becomes u power 3 over 2 over 3 over 2. And minus half. Okay, so let's plug in the limits. First, we'll convert the limits to limits of the upper limit becomes 0, and the lower limit is going to become 4 over pi. So this becomes 2 over 3, u power 3 over 2, minus half outside. Let's get away with that. Minus 1, the upper limit is 0, and the lower limit is 4 over pi power 3 over 2 divided by 3. Okay, so minus minus gives me plus, so I'm left with 4 over pi power 3 over 2 into 1 over 3. 4 power 3 over 2 is root of 4 is 2, 8, and that's pi power 3 over 2 into 1 over 3. I think I've proved that. Yeah, I have. So, tough question. Okay, to understand this integration, if you don't, you should go back and look at some integration by substitution questions where the integration is not provided to you. Okay, question number 7. Then it says every July, as part of a research project, Rita collects data about sightings of a particular kind of bird. Each day in July, she notes whether she sees the kind of bird or not, and she records the number x on which she sees it. She models the normal distribution x by this, where p is the probability of seeing this kind of bird on a randomly chosen day. Data from previous suggests that p is equals to 0.3, but in 2022, Rita suspected that the value of p has been reduced. She decided to carry out the hypothesis test. Okay, so I need to test whether this has reduced. In 2022, she saw 4 kinds of these birds. Okay, and the test statistic is 4. So I want to calculate probability of x less than or equals to 4. Okay, so I'm going to calculate the probabilities of 0, 1, 2, and 3. Okay, this would be 31C 0.7 power 31.3 power 0, 31C 1.7 power 30, and 0.3 power 1, 31C 2.7 power 29, and 0.3 power 2. I will have PS1 live streams soon. P3 has been going on for a while. You will find lots of live streams for P3 that have already been recorded. S1 के लिए this week you will find a schedule on my Instagram. Just make sure that you follow. And 4 as well. Okay. Point 0.0239. 0.0239 is less than 5%. Reject H0. There is evidence. That the value of P has reduced. Okay, in July 2023, she noted that the value of x and carried out another test at the 5% significance level using the same hypothesis. Calculate the probability for type 1 error. So I've already reached 0.0239. If I try to increase it and I want to add the probability of 5 to this, I'm going to use my calculator to do that and see if that works. Let's see what the probability comes out to be. The probability comes out to be 0.0627, which means that I've exceeded the 5% significance level. So this is not in the critical region. The critical region was up to less than or equals to 4. So probability of type 1 is the same as what we found earlier. Probability of the critical region, which is 0.0239. I'm lagging behind on the numbers, yeah. 0.0239. So I had to check, there was one mark for the method and then for the answer. Okay. Then beta models the same number of sightings y per year of a different very rare kind of bird by the distribution this. Use a suitable approximating distribution to find probability of y equals to 4. So when I say using an approximation, so what I'll have to do is I'll have to find probabilities. For continuity correction, I'll have to do this. Okay, all these numbers round off to 4. N and P are given to me. NP is going to be 365 into 0.1, 0.01. Okay, no, wait. Yeah, in fact, let's just do this. Okay, so this is a binomial right now. What I'm going to check is the P is very small. That sort of triggers the fact that this might have to be converted to a Poisson. Okay, so N is large and P is small, so this is a Poisson. I don't need to do a continuity correction because I'm not doing a normal distribution. Poisson gives me 3.65. Okay, so lambda equals to 0.365, so y equals to 4 e power minus lambda into lambda power r over r factorial. But in the past few past papers, I haven't seen this conversion, so I was a little surprised. 0.1922. Yeah, that's correct. I should round off all the answers to 3 significant figures. Justify n is large, greater than 50, p is small, less than 0.1. Those are the rules. Okay. Okay. That is it for this paper. I will see you with another paper in the next video. Thank you for watching.